So chapter 16 is in two parts. We'll do part 1 today and finish the other part on Monday. Today we are going to look at sampling distribution, the idea behind sampling distribution, also learn about proportions. So when I represent P hat, that is a sample proportion. Is that okay? So anytime you see a hat, it's the sample. So if you just see P, it means the population. Is that okay? And I've already explained what sampling is and also what population is. We're also going to use that idea to also solve problems. And why do we need samples? Usually, sometimes it is very difficult to get the entire population. That is one thing. The other thing too is that it could be very expensive to um, get the whole population. For example, if you want to do something about maybe American males, there are a lot of them. It's going to be very expensive for you to travel throughout all the states. So usually we try to rely on samples. Now we are going to talk about the sampling distribution, and I'm going to use an example to explain the idea behind sampling distribution. So, what is sampling distribution? So let's say that we have this population here. Okay? The population has so many people. All the dots inside this circle are people. Is that okay? So the idea is that let's say that we draw a random sample of 10 people from this population. Is that okay? So you draw 10 people. Add one more. So 10 people. Let's say you're interested in their average height. Is that okay? So you draw these 10 people, get the height and all of them, and then get the average height. Is that okay? That is X bar. Okay? So when you get the average height, we try to record the average height for these people here. Okay, let's say that the average height is, say, what number do you want us to use? Maybe 5.2. Let's say 5.2. So we have this graph here. We try to plot the 5.2 here. Is that okay? This is one sample. Okay. We draw again. Another people also get X bar. Come and plot. Okay. We do again. Get another X bar. Come and plot. So the sampling distribution, it means that we are drawing samples from a population, getting whatever we are interested in, if you're interested in their height, but we are going to do that many times. Is that okay? So for example, in this class, say we are 30 students and I'm interested in getting a sampling distribution and I'm drawing 5 people. I take these 5 people, get their height, put them back, draw another 5, like that. You do that many, many times. So as we are recording, we see we'll be getting so many of them and they're going to be stuck. So it's when you do that so many times, it's going to look like what? A bell shaped. Is that okay? So the sampling distribution means that we are drawing samples many times and then we are recording whatever we are interested in and then we plot that. Is that okay? So that is what it means. So one
X bar, does it represent like the average
yeah, so
height of all those
yeah, so
people?
that's what I was interested in. So that is the average height. Is that okay? Good. So that is what the sampling distribution means. So anytime you hear sampling distribution, we have a population, we draw the sample many times, record whatever we are interested in, and then we could be able to graph that. So that is what it means. Now, we are in this chapter, we are going to talk about proportion. So proportion relates to the what? It describes the fraction of the favorable outcomes in relation to the whole. For example, if I am interested in the number of males in this class. So the proportion will be the number of males divided by the what? The entire population. Is that okay? So the P here is the number of males or males in this class. That is my success. Is that okay? Does that make sense? If I'm interested in the number of people with green eyes in this class, the students with green eyes, they are my success. Does that make sense? And so their proportion is the number of students with green eyes divided by the number of what? People in the sample. Is that okay? So that is what? Proportion. And also, I want you to also know that we are going to use P to denote the probability of success. Is that okay? And then we are going to use Q to denote the probability of failure. Probability of failure, for example, what it means is that if I'm interested in the number of people, students with green eyes, P is the number of students with green eyes divided by the entire population. And then Q is the other students who don't have green eyes. Does that make sense? So then that is the what? The complement. So always have in mind, write this in your notes. Q is always 1 minus P. Q is always 1 minus P. Does that make sense? Q is always 1 minus P. And then this is for the population. So when we are dealing with the sample, then we are going to use P hat. Is that okay? P hat denotes the proportion of the sample. P is the proportion of the population. Does that make sense? So when you see the hat refers to the sample. Any questions so far? Okay, let's proceed. So how about the sampling proportion? It's the same thing. If you're interested in the number of students with green eyes, let's say we have this population here. And then I draw, so this is the population. And then I draw, say, 5 people. Okay, let's say 10. And then all I have to do is compute P. So let's P is say 0.3. This is P hat. That means the number of students with what? Green eyes here is 0.3. Is that okay? And then, so I draw this. So this is the sample. This is sample. I got the sample from what? This population. Is that okay? And then I just come and plot P is 0.3. So let's say that is somewhere here. So, and then we do again. We'll get another P hat. We'll do again. And then when you plot all the sample proportions, you should be able to get something like what? A bell shape.
So to get P hat, is that when you divide like the number of favorable outcomes over the population or the sample?
The sample,
The
yeah.
sample, okay, and that's how you would get
Yeah,
0.3.
that's okay. Because if I took, say, 10 people and then 3 people have green eyes, it's going to be 3 over 10.
Okay.
And then you draw another sample. Is that okay?
Yeah.
Yeah. So you you draw many samples. Whenever you draw a sample, you record your P hat, you plot it, you do it, you record your P hat, you plot it. When you do it many times, you are going to get a bell shape. That has already been proven. So that is the idea behind sampling proportion or sampling distribution. So I also want you to, so what it means is that we already know that when the sampling distribution of the proportion is always what? Bell-shaped. Is that okay? And so the mean is what? P. Is that okay? And then the standard deviation is given by, so the standard deviation of the what? The sample proportion is given by this. So I want you to write this too in your note or in your sheet. This is the standard deviation of the sampling proportion.
Wait, so with the mean being P, does that mean like the mean is the same thing as the probability of success, or those two separate things, just to note it's not the
So,
same thing?
so what it means is that if you draw the sampling many times and then you average all of them, you should get a true population.
Okay.
So I want you to be able to write, this is the standard deviation of the proportion, and then the mean is given by this. And so, like I told you, that when you do that many times, we are going to get a bell-shaped. So we assume the normal distribution. And so if anytime you ask to find the distribution, it means that this is normal with a mean of P and then a standard deviation of what? Square root of what? PQ over N. So I want you to also write this too in your note. Now let's open homework 16 and then let's try question 1, 2, and 3. So let's try question 1. So take your time and read question 1 and tell me, what do you think the answer is? Why do you think it's unimodal and symmetric?
That's a bell curve.
Yes, that's a bell curve. Is that okay? So for example, when you have a bell curve this way, unimodal means that it only has one peak. This has one peak. Is that okay? And then symmetric means that what, it's like a bell shape. It's not skewed. Is that okay? And then this is what the sampling proportion looks like. So that is unimodal and symmetric. Now, the next question is that what would be the mean of this sampling distribution? So read it and tell me what the mean would be. What do you think the mean would be? Anybody else want to try? What do you think it's going to be? Adlin, what do you think it's going to be? Bless you. Why do you think it's going to be 0.34%? Good. That's correct. So when you look at this one, you are given that the true proportion. So the true proportion is what? P. You are given that the true proportion is P, where it is 0.34. We just learned that what the mean is what? P. Is that okay? So then that is the mean.
Is true proportion and like probability of success, like
Yes, the same.
same thing?
Yeah.
Okay, okay. That's what I was-
The next one is that what would the standard deviation of the sampling distribution? I just asked you to write that down. So we know the standard deviation. Right? And then we already know our Q is equal to 1 minus P. Does that make sense? So let's get our Q. If P is 0.34, what do you think Q would be? Q is going to be 1 minus 0.34. What would you get?
0.66.
0.66. And so we have standard deviation equals square root of P 0.34 multiplied by 0.66 divided by our N. What is the N? What would you get? So you can see that the P is 0.34. And then the Q is 1 minus P, which is 1 minus 0.34. And then you can use the formula we discussed in the slides to get that. When you do that, what do you get for the Q?
Wait, so what is N? Is it the whole sample?
Yes, the sample.
Okay, okay.
And remember, the square root extends here. It doesn't end here. It extends there. So you are better to find this times that divided by this, then you find the square root of the answer. Is that okay? So when you do that, what do you get? Anybody wants to share the answer? Zero 0.023. Yeah. Now let's get to question 2. To read the problem and then tell me what A should be. Why do you think it's 0.49? Okay. So also when you read, you are even told that the proportion of what adult women in the geographical region is what 0.49. And then the survey, marketing survey telephones 500 random. And then you ask to find what proportion of 500 would you expect to be women? Now, the next one is that what would the standard deviation of the sampling distribution be? Same thing. So do it and then tell me the answer. So what is P here? P is 0.49, right? What is Q? 1 minus P, 0.51. And then what is our N here? 500. So try to do that and tell me the answer. So you can do that and then put that in your homework. Anybody wants to tell me the answer for B? Okay, C. C says that how many women on average would you expect to find in the sample of that size? How did you get that? Yes. So to be able to find the how many women on average you would expect. You just multiply the proportion by the sample. Is that okay? So for example, if it were to be 50-50 and you have 500 people, we expect 250 of them to be women. Does that make sense?
So you would do like 0.49 times 500.
500, yeah.
That would give you the
The number, yeah.
expected.
Because it says that how many women. So we are looking at what the average, the number. And what did you say? 250 what? 245?
Yeah, 2.5.
Okay. Now let's get to 3. So for 3, you read the problem and then I click on this one to look at the histograms. So this is the histogram. Can we all see that? So when you look at the histogram, when you look at this one, look at the sample size of 20. Look at how it looks like. So what shape is this? This looks like left skewed, isn't it? Right? When it's 50, also kind of like left skewed, but yeah, you can see from that. And then this is when it's 100, it's looking better. And then when it's 200, you can see this is what? Symmetric. Is that okay? And so then the question is asking you that as a sample of the histogram increases, the center of the histogram, what happens to the center of the histogram? Okay. Anybody else?
Could you repeat the question?
So the question is saying that as the sample size increases, look at this histogram here, okay? As the sample size increases, what happens to the center of the histogram? So the center is what? The middle. Is that okay? Yeah. So the center, look at the center. You see, it stays the same. Does that make sense? What is the center here? The center is somewhere here, isn't it? Look at the center here. Same. Can you see that? The center stays the same. And then as the sample size gets bigger, or when you increase the sample size, what is the shape of the distribution? So when your sample size increases, look at the shape. This is like left skewed. Now look at this one, and then now look at this one. You see, as the sample size increases from here to here to here to here, it's becoming what? More normal, right? Do you agree with that? Okay. And then the variability in the sample proportion. What happens to the variability? Does it increases, decreases, or stays the same? Why do you think it decreases? Yeah. Yeah. So you can see the variability what decreases. Can we see that? Okay. And say they said this simulation, what does it do? It appeared to demonstrate the central limits theorem, right? So that is how to answer 1, 2, and then 3. Let's go back to our slides. Now, the next thing we want to talk about is assumptions and then conditions. So what this section is trying to explain is that before we assume the bell curve, so for example, when you go take proportions from samples, before you assume that it follows the normal distribution or before you assume that it follows normal, you have to be able to make some assumptions or check some conditions. So the first condition is that the independence, you should be able to assume the independence assumption, which means that, for example, if I'm using the sample distribution, it means that me selecting the samples from this class should be what? Random. Is that okay? And then me selecting Kodak should be different from me selecting somebody else. Does that make sense? And then the individuals must be what? Independent of each other. And then they should also be what? Random. So these are some assumptions that you have to be able to what? Make. So it's very good that you write these assumptions down because there are some problems that would ask you to check the assumptions, or there are some problems that would ask you which assumption does this violate. Does that make sense? So these first two, and the other one is the 10% condition. So the 10% condition says that what? It can be a problem if the sample size is too much. For example, if this class is 30 and I'm taking a sample of 20, that is too much. Is that okay? So the 10% condition means that the sample should be less than 10% of the population. Does that make sense? That is the 10% condition rule. The sample size should be what? Less than what? 10% of the population. And then the last condition is that what? As the sample size gets larger, n times p and then n times q, n times p and then n times q should be both at least 10. Is that okay? N times q and then n times p should be at least 10. If these conditions are met, then you can use the normal model to model the sampling distribution of the proportion. So to be able to do that, let's go to chapter 16, question 5, and then try. Let's try chapter 16, question 5. To read the problem and tell me which condition would be violated here. So we know 4 conditions. We know the independence, randomization. So when you look at this one here, though we know independence randomization, we do not, we see the independence. We don't care about the independence because choosing between A, B, and C, there is no independence. Is that okay? So we are going to focus on randomization, the success or failure condition, and then also the 10% condition. So when we read the problem, it says that you drop by a local independent coffee shop on your way to class. While standing in line, you notice that 85% of the 20 customers are texting. Assume these customers form a reasonable random sample of all potential customers. So you've been told that these customers form a reasonable random sample of all potential customers. If we try to make a confidence interval for the proportion of texting customers, which condition will be violated? So we can see that the 10% condition has not been violated because we have been told that you should assume that the random sample, that these customers form a reasonable random sample. Does that make sense? You have been told in that problem. So the 10% condition has not been violated. Does that make sense? You have also been told that what? It forms a reasonable random sample. So randomization is also okay. Does that make sense? Now, how do we?
I was gonna ask, so for the Seth/Miller condition,
Mhm.
it says that like what is Q hat?
Q hat is 1 minus P hat,
Okay.
or 1 minus P.
So and like the P hat is the standard deviation of P, right?
I don't get what you mean by that one.
Like
So, for example, in this problem, P hat is 85. Is that okay? If P hat is 85, what is Q hat? 15. Does that make sense? Good. So now let's try to do the failure or success condition. It says that N times P and then N times Q should be at least 10, right? So let's try to do that. What is N? N is 20. So N is 20 from here. Is that okay? Now, let's do N. What is P hat? 0.85. What is Q hat? 1 minus P hat, which is the same as 1 minus 0.85. Is that okay? What is NP hat? 20 times 0.85. What do you get? 17. It means that we see that NP hat is at least 10. That is checked, isn't it? Now let's do NQ hat. What do you get? 3. The condition says that both should be at least 10. Is that okay? This guy is not. So it means that what this condition wasn't met. Does that make sense? Okay. Any question on that?
It's like he was also mentioning it, that like, in the slide earlier, when we were doing like the formula for standard deviation, it did have like standard deviation was equal to like P hat. And it was like, so I'm a little confused, cause like, it seems like P hat is like the standard deviation, but it's also like the observed proportion.
Okay. So the point is that P hat, this P hat here is the proportion of the sample. Is that okay? This P hat is the proportion of the sample. So for example, if I take 5 people and then their P hat is 0.2, another 5, P hat is 0.8, another P hat. So this sample is this sample is that, this sample is that, so many of them. Is that okay?
Okay.
So
there's
this,
just
this so many of them, what is their mean? Does that make sense? What is their standard deviation?
Okay,
Does that make sense?
yes.
So that is why you have SD of P hat. So the standard deviation of all
Oh,
these P
okay,
hats,
it's standard deviation
of
of P
all
hat.
these P
I
hats.
thought it was saying standard deviation is P hat, but it's
No,
standard
deviation
deviation
of
of all the
P
P hats.
hats.
Okay,
Yes.
thank you.
That is why it's the sampling distribution of all of them. Does that make sense? So this P hat here is just the sampling proportion of one sample, the sampling proportion of another sample, sampling proportion of another sample, so many of them. Does that make sense? This SD, so for example, if you've done it so many times, are you going to explain to somebody that, oh, the first one is this, maybe you have 1,000 of them, that you are explaining to maybe a board or your company, you are not going to say, oh, the first one is 0.2, the second one is 0.8, it's so of them. So you could say, well, the proportional, the true P is this and the standard deviation is this. So it's all of them. Does that make sense?
Okay.
Now let's get to the slide. Now we want to do an example, okay? So this example says that it is known that red or green color blindness affects 7% of American men. Is that okay? And then a school district gives a test to 233 incoming kindergarten males. Let's define our random variable. So you could define your random variable to be what? This is the random variable. So the random variable could be what? P hat to represent what? The proportion of what? Color blindness among American men. Is that okay? Does that make sense? I also have the solutions here too. So this is P hat, the proportion of what? Kindergartens who are colorblind. The next condition is what? The next question is what? To check the conditions. Now we want to check independence, randomization, the 10% rule, and then also, let's check for. So we want to check independence, randomization, the 10% condition, and then also the success or failure condition. So you just want to check that. Now, when you read the problem, it doesn't say anything about randomization, or it doesn't say anything about independence. So we are going to what? Assume that. Is that okay? We are going to assume that it's what? It's independent, and also these 233 people were selected at what? Random. Is that okay? Then we could also assume. Now, when you look at 233 men, these 233 sample of kindergarten males, we can say for sure that it is what? Less than 10% of the what? The population of American males. Is that okay? American males are, when they are more than like 2 million, more than 2 million or 10 million, and then 233 is less than 10% of them. Is that okay? So the 10% rule is satisfied. Now we can also check the success or failure condition. How do we check that? What is P? P is what? 0.07. So NP hat is 233 times 0.07. What do we get? What is 233 times 0.07? That is what? 16.31. Is that okay? That is more than 10. Okay. Now we check NQ hat. NQ hat. So we know Q. What is Q hat? 1 minus what? P hat, isn't it? So we know Q hat is equal to what? 1 minus 0.07, which is what? 0.93. Do you agree to that? That is Q hat. So NQ hat is what? 233 times 0.93. You multiply, and you are getting something like 216.69. And then when you look at both of them, they are more than what? 10. Does that make sense? So those conditions are also what? Satisfied. Now the next question says that what? Give the sampling distribution. Remember what we learned from here. What is a sampling distribution? This is a sampling distribution. Is that okay? Does that make sense? This is a sampling distribution. And so when you ask to find a sampling distribution, it means that what? We know that the mean is P. So the mean is going to be what? 0.07. And then let's try to find a standard deviation of P. This is going to be what? Square root of P 0.07 times Q 0.93 divided by N 233. What do you get? 0.0167. Let's see. Yeah. So you see, this is a sampling distribution, the P and then the standard deviation. Does that make sense?
Could you go back like to where you were doing the work?
So anytime you ask to find a sampling distribution, remember what I asked you to write in your notes here. It's here. So this is a sampling. So we find mean and standard deviation. Is that okay? That is a sampling distribution. So the mean is this, which is the same as what? P. And then the standard deviation is this. Using the formula, we know that what? ST of P hat is equal to square root of what? PQ over N. Does that make sense? And then we just plug in. Always know Q is 1 minus P. It's just the complement of the other. Does that make sense? If it is, it's the same thing. If it is hat, it's a sample, same 1 minus P hat. It doesn't change. Does that make sense? If you see hats, don't be confused. It means sample. Does that make sense? Good.
So P is like the same thing as P hat, but P hat's just the sample. Or
yeah, P hat is a sample. P is a true population. They are the same. Does that make sense?
Yeah.
Just one is for sample, the other one is for the population.
Okay.
Good. Now, the next question we want to do is, let's try to answer 4, 5, 6, and 7. So for us to answer 4, 5, 6, and 7, we are going to use StatCrunch. You can use StatCrunch to do that. Now, let's go to StatCrunch. We are going to input the mean to be 0.07 and then this to be the standard deviation. Is that okay? So let's go to StatCrunch and then do that right away. So StatCrunch here. Now let's go to stats, calculators, and then let's get to normal. Okay, go to stats, calculators, let's get to normal. So you see, we are here. What is the mean? The mean is 0.07. Is that okay? What is the standard deviation? The standard deviation is what? 0.01675152. Okay, then let's get to the first question. The first question says that what is the probability that more than 10% of these kindergarten males would be colorblind? So to be able to get more than 10%, we click on this one and change this one to greater than. Is that okay? And then I put here 0.10. That is 10%, isn't it? Does that make sense? I put in the mean, the standard deviation. Now, the first one says that what is the probability that more than 10%? So if you want more than 10%, you change this one to be greater than and then put 10%, hit compute. You get 0.0363, whatever you have. Does that make sense? So that is for that. Now let's get to the other one, 5. What is the probability that fewer than 5% would be? So fewer than 5%, we change this. This is less than, let's put 0.05 here. And then we hit compute. That is fewer than 5%. Does that make sense? The next one will be the probability between 8 and 12%. So 8 and 12%, we have to change this to go to what? Between. Is that okay? Between, and then put here to be what? 0.08. Change here to be what? 0.12. And then we hit compute. And then we get that. If you want the 75th percentile, we come back to this and then just put 0.75 here. 0.75. And then you hit compute, it gives you the 75th percentile. Is that okay? So on Monday, we would proceed with the part 2 of this.